Hello everyone, welcome to AI Anytime channel. In this video, we're going to look at CodeGemma. So CodeGemma is a new code based LLM, that has been created by Google. It's based on Gemma model, of course. The earlier you would have seen that a couple of months back, Google came up with the open source LLM. After a while, they put their feet in open source landscape, and they came up with Gemma model. Now they have released two models, Code Gemma, Recurrent Gemma, and these two models. But we're gonna focus Code Gemma in this video. They have three different variants in this. So variants are two, 7B and 2B, but there are three different models weights that they have released. In 7B, there are two models, Code Gemma 7B, Gemma 7B IT, which is the instruction tuned model. And then we have CodeGemma 2B. So there's a 2B variant as well that we have. Now, the underlying, the concept remains the same. Gonna generate something for the 7B and gonna complete for 2B. So if you want to, perform natural language like task using the CodeGemma 2B, probably that's not the model for you, okay? Because it has been created for code completion, not generating code based on natural languages. It does not perform that well, but I will show you with that model only that I'm gonna perform ask questions, generate Python codes and things like that using 2B only. Not gonna rely on the 7B. Okay, but we can try 7B as well. That's not a problem. Now, when you talk about how they have been trained, the 7B model has been trained on 80% of the code corpus and 20% of the natural language corpus, the text corpus. That's how the data distribution have been for the training, when the pre-training part, and then have been the instruction tuned as well for the CodeGemma 7B IT. For the 2B model, the only data corpus is 100% code. That's what they have done. Okay, and they of course it has been done at probably DeepMind. They would have been created this model, and this is what we're gonna show. It has performed good. I have tested it out, and I'm gonna show you for a few of the questions and how you can do that. Now, if you look at here on my screen, let me just wear these glasses now. CodeGemma 7B by Google. It's a gated model, so if you want to test this out, you have to acknowledge the license. Okay. Uh, so as I said about the pre-training and the instruction tune. So the pre-training part. So guys, right? So you have to understand. First, there should be pre-trained to get a base model. Then that there should be further fine-tuning for downstream tasks. Like if you want to train an instruction tune, you will not immediately do that. Okay. So you'll first create a pre-trained model, and then you will uh, probably align it or further fine-tune it, enhancing the model's logical reasoning and capability. And that's how the instruction tune have been done. Okay. Now they have performed well on some of the coding capabilities. I have checked for Python. They have the language capability for the 7B model, and this is what it is. Okay. Now let's go back and see how we can try it out. It's available on Google's Hugging Face repository. You can see it over here. It says CodeGemma 7B, and you can find out uh, different things over here. So this is the table that you should go through it. So code completion is available on CodeGemma 2B. Generation from natural language is supported in both the 7B model, not the CodeGemma, chat and instruction following. But I'm going to show you a few examples with CodeGemma 2B only that it does the job. They have given you some code completion, some prefixes, some suffix to put that in a prompt template kind of a thing. Okay, that basically different parts of the input. That basically creates a separation. Now, I'm already have installed transformers and accelerate. I'm using Google Colab. Probably you need a basic GPU. T4 GPU will be enough for 2B model. So feel free to use that. Now after doing that, I'm gonna do from transformers import Gemma tokenizer. So it has a Gemma tokenizer, now the part of transformers class. If you are working with the llama model, probably you will be using a llama tokenizer. Now this is done. I'm gonna have auto model for causal LM because we're gonna generate something. That's why I'm gonna have this. And the other thing that you need is for that, let me go to my Hugging Face. Yeah, this is what we're gonna do. We're gonna do a notebook login, guys, because the model has uh, a gated. It's a gated model, so it sits behind a kind of a wall where you have to first go and acknowledge the model licenses and things like that. Then that's why we need access tokens. Let's get the access tokens from here, and I'm just going to copy any one of these. These are all having read accesses, so I am able to inference that. Let me just do that here, and I'm going to pass this, and this will validate. Okay, now you can see login successful. And after that, let's get the tokenizer. So I'm gonna do whew, tokenizer equals, and then I'm going to pass Gemma tokenizer. Gemma tokenizer dot from pre-train. Let me just get rid of model as of now. Okay, we don't need. Let's focus on this. Gemma tokenizer dot from pre-train, and this is not the model that we have. It should be whew, it should be Google. So let me just go back here. Okay, and let me just copy this, and this will get the tokenizer. So let's get the tokenizer. And you can see we are done with our tokenizer. It gets the config JSON and tokenizer JSON with the special token map JSON files, and downloads the tokenizer. Excuse me, I have a sore throat. Now you have a tokenizer model which is 4.24 M. You can see it over here. So we are done with that. Now the model, and the model is again, it said it would come from auto model for causal LM. So we are not doing a mask language modeling. We are generating text. That's why we're using auto model for causal LM from transformers. And then I'm going to pass my CodeGemma. Let's pass. Oh, I passed 7B. Let's pass 2B. I'm going to try with the 2B model. Okay, so I'm going to pass 2B over here. And you can see then this is fine. This is fine. This is fine. Let me just refresh this. And this goes 2B. Device map auto is fine. And I'm going to remove this, by the way. And I'm gonna pass torch D type. Okay, so let's just get torch D type equals, and this is going to be auto. And let's run this now. It's going to download the model, and we're gonna test this out for a few. You can probably take the code from Hugging Face repository as well. The idea here is to test some prompt and see how the model is performing, because the size, to be size, you'll be able to run it on CPU as well. So if you have compute limitations, I'll recommend that you should check this model out, right, on some of the use cases that you'll be probably working with. And this is a great that's a great effort by Google, I will say, to release this code-based model. We earlier have had stable code, and 5.2 are also generating good code. So we have stable code, which is around 3 billion, and also there was a 1.5 billion model as well. And this 2 billion model, it performs well, then we can bet on this, right? For some of the coding use cases like generating code, test cases generations, code refactoring, code review, and whatever we do in the SDLC life cycle, software development life cycle, you will be working with different use cases. And if this can work on CPU, in tandem with some other smaller models in an enterprise, that's what you need, right? So let's test it out. So I'm going to do a prompt here. So prompt equals, and I'm going to say, let's write out with a fast API framework first. So write a Python fast API uh, function for calling a weather API. Okay, this is, and I'm using a natural language, guys. Here, it's a bit of natural language understanding here that models would has. Okay, that's why probably it will be able to generate, otherwise it will fail. And let's have inputs, and then I'm going to write inputs and tokenizer. So tokenizer, and then pass the prompt. So prompt has been passed, and then return tense or pt, and then I'm going to bind that with model.device. Okay, so whatever it, because we have that device thing it done. Let's run this, and if you just say inputs, you can find out all the tensors. Okay, you can again decode this out if you want to do that. Okay, now we'll not do it yet. Okay, we're going to decode the output that once we generate. So I'm going to say prompt length equals, I'm going to pass input and then have an input IDs. All of these had IDs. If you look at over here, it has IDs over here, and that's what we're going to pass here, input IDs, and then just save. That was right, but it should be -1. Okay, now save. That is done. Method object is not subscriptable. What did I made a mistake? Oof. Prompt length input. It should be inputs, not input. And prompt length, it says input IDs. Oof. Let me just run this again. Again, inputs, and that should be input. I'm making a mistake here. That should be input IDs. And now if you do a prompt length again, yeah, 13 as you can see. Fantastic, right? These are all we used to when earlier we started our career, guys, we used to focus on all of these. What is tensor? We started learning all of those intricacies and all of the deep dive, into tensors, finding out loss functions or whatever. I'm not going into this, but these are the fundamentals that you should understand. Now let's use model.generate. So outputs equal. I'm writing it right. Output, and then I'm going to use model.generate. So model.generate, and then I'm going to pass inputs and max new tokens. Let's keep it is probably 150 or something. Okay, so as max new tokens, it will take a bit of time, guys, to generate. And then we're going to print outputs. And let's print the outputs. Once you print the output, you can see you get a set of tensor over here. Now we have to decode this. So we're going to decode this. So let's do that. So I'm going to do print and tokenizer.decode outputs 0, and then we don't probably need that. We don't need to skip. Ah, so this becomes this output 0, and then I'm going to write prompt len and colon. This should make sense. Tokenizer.decode outputs, and you can find out. Fantastic. And of course you could have used skip special tokens too then to get the better output. Now, if you look at this, I'll make it a bit bigger. This is the right answer, at least for this kind of model. I accept this answer, guys, for this. Let's see, it gives you define get weather, and we have of course import request. Define get weather URL. This is the open weather map. So this is able to understand what kind of question I'm asking. So it got that. Then data response JSON and return data, and then city input enter weather data get weather. Fantastic. I mean, I liked it. This is the right response for this question that we asked. Let's ask some other questions as well. Okay, so this is the question that I've asked. Okay, and probably I'll just copy this here. Prompt would have created a function. Just let me make it a bit small. 110%. This is fine. After prompt, let's get the prompt length here. So not this tokenizer inputs tokenizer. Here goes the tokenizer, and then we're gonna use prompt length, and this makes sense, guys. Okay, let's change the question now. So what I'm gonna do is, what question we can ask here? Let's ask. Uh, I want to ask a tough question. Okay. The question. Let me think. How to write the code? Write the code in Python, or let me try it out one thing. Okay, I'm increase the max new tokens to 250, and I'm going to take a doc string. I'm going to copy this just this piece of code that it has generated, and let's try it out an interesting task. Okay, I have copied this. Okay, this is fine. I mean, that is fine. So let me just get this rid of this. Let me just get rid of this. And then what I'm going to do now is ask a question, write the test cases for the function. Let's generate this now. Let's see if it's able to get that. Nothing. Okay, so didn't get that. Okay, so just a 2B model. It's not good for, probably generating test cases out of it on natural language on this large code snippet, because that's the code snippet that you are putting. It's more of generating code or the code completion. But yeah, but 7B model would have got that. Okay. And let me see what's wrong in the code. It's not getting anything now that we have prompt. We're passing the prompt. Now let me ask to generate a question and see if it's able to get that. I got a Python fast API, not that question. Now I'm gonna ask a simple question, right? Write a Python code to generate 1000 random numbers or random integers rather in integers, and it is given you. So that's the idea, right? So it's good for generating code, the 2B model. So with the 2B model, as it has said here as well, that probably will not work out. You probably need a 7B model to work with that. 7B model to does the inferencing and all of those things that we wanted to do it here. Okay. Now you can make a change here as well. Okay, if you make that a 7B, you get the 7B thingy. Let's try it out. Probably I should not get a CUDA out of memory error because 7B model I'll be able to use on B100 even if I have something in the volume. So when I say in the volume, the 2B model it has been persisted in the volume on Google Colab. So it should probably not throw me an error because that does not require a lot of GPUs, probably a lot of space. It's not about GPU, it's about the space as well first, that it should not say that no space left on device. And then we'll try to load this on V100 and see if it's able to run it. If not, then probably I have to delete the runtime, disconnect and delete runtime and start again for the 7B. But I just wanted to check this out, okay, and that's why let's try it out and see what required. Okay, you can see it's getting all the models. Whew. And I want to ask the same question, guys. Okay, so let me just copy it here. Write the test case. Write the test cases for the function, and then below goes my function. Yeah, and this is fine. If it's not able to understand this piece of code, then it's not a good model. I will not recommend to even use that model. If it asks this question, it's not able to understand what I'm asking, the 7B model, then don't use it. Okay, let's try it out. So you can see that it's downloading the shards, two of it. I'll just close this. I don't need it now. So let me just get rid of this, and this. And then we have the prompt thingy and the inputs, and then we'll be able to run the model. Let's try it out. If we don't get a CUDA error, we are okay with it. It's now loading, and that's the main thing. So let's see if it's able to load in the memory. It says some parameters are on the meta device because they were uploaded to the CPU. So sad, I think. Yes. But yeah, again, you can delete and disconnect the runtime. And you can see EOS. Probably I'm not doing the what they recommend to do. If you look at here, they say this prompt, import date time, blah blah blah. Let me check this code. Okay, copy it, come back here. I'm just gonna paste it. What's wrong? Calculate. I can get rid of this. We don't need this here. Okay, and let me just get this entire prompt thingy. Okay, I'll get rid of this prompt here. This is good. Import date time. What next? Okay, if I am middle, let me first run this, guys. Okay, we're gonna run this and try to let me first run this and see what happens. Okay, but I am more interested to find out the capability of to see if it's able to handle complex software development use cases. Otherwise, we have better model like Star Chat, Star Coder, Widget Coder, Code Llama, and the other LLMs for coding that we have, the coding purposes. So if it's not able to understand these kind of questions, very difficult for to go and use it because it gives me the same thing. Okay, calculates a person's age based on the birth year, blah blah blah. Import date time, if I am prefix, if I am middle. Okay, this is fine. Now you can try it out and let me know your views on. I don't want to extend this video any further. Okay, you can try it out and let me know your views on uh, CodeGemma model. What do you think? of the performance on different use cases. I liked it, the 2B model for generating code, the smaller code snippet. Probably those are helpful if you are building a plugin or extension kind of a thing, for any code editor or the Chrome extension or whatever, or to generate simple code bases, for a given use cases. You can try it out. Now this will be available on GitHub repository if you want to use this notebook. I'll paste that link in the description. And that's all for this video, guys. If you like the video, please hit the like icon, and if you haven't subscribed the channel yet, please do subscribe the channel. That basically motivates me to create more such videos in near future. uh, Share the video and channel with your friends and to peer. Thank you so much for watching. See you in the next one.